Hello guys, this is Jeffrey. I've gotten a video here on interfaces, and I'm also going to discuss here a little bit more advanced polymorphism than what we have covered previously in the discussion of inheritance and polymorphism. So an interface is in a lot of ways similar to an abstract class. It can't be instantiated, and it lists a series of abstract methods that must be implemented by anything that implements the interface. The differences are, well, they're pretty basic. First of all, you can implement as many interfaces as you want. In inheritance, you can only inherit from one class, but using interfaces, you can implement 10,000 interfaces if you so please. The next big thing is that interfaces themselves are not actually classes. They can't have all the same data members a class can have. So whereas a class can have a greater variety of variables, including protected and private variables, interfaces are limited to only having public variables, and all their methods have to be able to be overridden. And the next thing beyond that is that interfaces are more lightweight than a class. Typically, you want to use an interface if you are designing a program where you want a relationship between a set of objects, but you don't want to have any big overhead between that. Interfaces are a much more lightweight way of doing things, and they can be added on to existing code much easier than having to go through inheritance. So an interface is declared very similar to a class. You use almost always use a public interface and then the name of the interface, and then below that, the declaration here, the code inside, looks a lot like what you see in a class. You can have instance variables here. They can be static or final or neither. They have to be public though. You can have abstract methods. No, you don't have to use the abstract keyword here, although you can. It's not necessary, and it's really just a style choice. And then you can have methods that have implementation. These are called default methods, and you have to use the keyword default when you declare a default method in an interface. All that says is it's suggesting a implementation of this method. All default methods in interfaces can be overridden by anything that implements that interface. But that's really the basics for the interface structure. Anything that implements the interface is going to, in a sense, inherit anything in here. I use the term inherit loosely. It's something that you'll be very familiar with, having studied inheritance, but at the same time, it's not the same as inheritance. It's the best way to say it is implementation. You're implementing this interface and using the data and methods it has to do that implementation. So right here I've got two interfaces, one interface 1 and the second one, much simpler, interface 2. Both of them are defining or rather stating abstract methods, and both of them are being implemented by two different classes in my simple program here. One of them is a parent class, and one of them is a subclass of that parent I call class A. So notice, just to walk through this, in the parent class I'm implementing interface 1. So in order to do that, I have to overwrite the method, and I've done that right here, and it simply prints out I've implemented method. Pretty simple. I don't need to do anything else in here besides that. And notice that right now, class A is extending parent. Since this method right here is public, it is inherited by class A, and class A is an implementation implicitly of interface 1 because it extends an implementation of interface 1. So class A right here is actually implementing two interfaces. It's implementing interface 1 because its parent class implements interface 1, and it's explicitly implementing interface 2, which is added functionality to this extension class A. So you can see right here, I've defined another method, which is the method that you have to do according to interface 2. And I've also defined, or rather I should say redefined method. And note here, I can use polymorphism to access the superclasses method, parents method, and I can also overwrite that and do something here. So when you're using inheritance, there's even more room to add polymorphism into this, and more ways you can redefine functions by combining inheritance and implementing interfaces. So when I go back over to main here, I've got a brief description of the last thing you need to know about this. and that's how you declare data members that extend an interface. So as I mentioned before, so parent right here is implementing interface 1. I can say parent B equals new parent, but I can also replace that and say interface 1 E equals new parent. And since parent is implementing interface 1, it is considered of type interface 1 also for this scenario. If you remember back on the video about arrays, I mentioned you can say list name equals new array list. That's the same thing as I'm doing right here. List is an interface just the way interface 1 is an interface. Parent is an object the same way array list, or rather I should say a class. Parent is a class the same way array list is a class. And all you're doing here is you're saying explicitly, I've got something of class parent, but I want the compiler to treat this as the interface because I'm only in this scenario calling methods required by that interface, and the only real difference is how they're carried out. So that's why you would do that. You don't have to, but it can sometimes help make it more explicit why you have a certain class in the code. It's more obvious when I declare it this way right here that I'm using it for the interface methods than when I do it right here, in which case you would be implying that I'm using this class as primarily what it is, and it happens to implement that interface also. And so notice I can do something even crazier with class A. I can declare it normally, or I can say interface to class A equals new class A. Or C, I gave it the name here. I could write class A too. Spelling helps. And I can also say interface 1D equals new class A. Since class A is implementing both interfaces 1 and 2 and extends parent, I could even go further and say parent, capital P in parent, P equals new class A, and that even is going to work also. So this sort of thing you see here is something the AP test likes to work on and to test you on because it obfuscates things, and the AP test loves to have things that don't look like what that aren't what they look like they are. And just to highlight some of the points I was making before, I've got a list of printing out off of the object of class A right here that I call A. When I call a.method, it's going over here to method, printing out the super implementation of that, and then its own. That's what you see right here. In the call to another method, you're just printing out I've implemented another method. That's the only definition of that method that there is. And then for method 2, note that in class A I never actually said that I'm changing method 2 at all. So it's just referencing in this interface that method 2 right there and printing out hello as it was defined in the interface with the default value. So that's really about all that there is for interfaces. I'd say watch out for the polymorphism that comes with these. Be aware that you can do a lot of crazy things with this. And then also be aware that, let's say, this is a point I also made talking about inheritance, but it's worth repeating here. If I say something like public void, let's call this function, and I'm going to leave it as a stub. It doesn't really matter for this example. I've defined this function right here. If I try and say, hey, I've got this thing that's of type class A declared as interface 1. Just like before, if I do d.function, the compiler is going to yell at me and say, what do you think you're doing? The interface doesn't have something called function. Just the way that when you extend a class, just the way like I couldn't do b dot, here, let's say I change this implementation here. I could not do a.function either, even though class A does have that function. Just the same way that happens in inheritance, it happens with interfaces. Whatever you declare it as is what the compiler thinks it is, and it limits what functions you can call using it. So just be aware of that little discrepancy there. That's the kind of thing the AP test will be looking for. I don't think the AP test really does much in terms of testing interfaces, but they're very good to be aware of, especially considering that there is so much in Java that relies on interfaces between lists, comparators, runnables. There's a whole lot of those flying around out there. So I'd just like to end this video real quick with just to show you a very popular interface called comparable. There's only one method in this one. It's called compare2. And I know you guys have seen this before with the string. You can do string, make an object of type string you can call compare2 on, because you can't use greater than or equal signs with strings. This compare2 is defined in the comparable interface, and it allows objects to be compared by whatever implementation you give them. So this is kind of useful if you want to do automatic sorting of something. In the arrays class, there's actually a method called arrays.sort, and you pass it an array, and if you can pass it logic on how to compare something. And it's for uses like that you really want to see comparables, because if something has a compare2 method and you pass a comparable into a function, it can just start calling down comparing methods and starting to sort like that. So that's one very useful use of an interface. And note, since in that scenario you care about its functionality as an interface and not its functionality as the object, you would, in the method receiving this comparable, write, for example, comparable C, not string C, in the method header as the parameter, because you don't care what its function is as a string, you only care what its function is as a parameter. Going back to the reason whether you declare it as interface 2 or interface 1, or if you want to do like declaring it as class A, it's the same thing. It depends on the functionality you want the program to see and you want the compiler to see when that comes in. So yeah, that's about it. Thank you guys for watching, and goodbye.